Alright guys, hopefully you've worked on problems 2 and 3. If you haven't, this is your time to do it. I'm just going to work it out really quick. So now the person's still pushing, but it's the same as last time. This time, by the way, I realized in the last worksheet, or last video I didn't explain. We're in worksheet 1 of unbalanced forces, so hopefully you're over there. So worksheet 1. We're still on there and we are moving on for these problems. Alright, so we have Fn going up, Fg going down. That's the same. We still have force applied. This time we have added a force friction. Alright, and when I draw my VAD, once again, I'm drawing this all, and what I notice is, hey, I still have this gap here. Even though I have force friction going over, it doesn't completely fill in this gap. So that gap, we call that the net force. And we had seen this net force before. So on this problem here, we notice, I highlighted there, but we noticed there's that net force there. Now the way to think about this net force, like what direction, the direction of the net force is the direction it's accelerating in. It looks like in this problem, it's still going right. You can imagine this arrow attacks this part of the arrow, but this part of the arrow is left over, and that's what the net force is gonna be. All right, let's solve for this. All right, for the same reasons as last time, Fg is still 100 newtons. Mg, you end up getting 100 newtons. Fn, it's still balanced vertically. All right, let's talk about this. They give us that friction is 3 newtons and applied is 10 newtons. But now let's try to find F net. So I'm going to do that same method I did before, summing the forces in one direction. All right, horizontally. I only care about horizontal. I don't care about vertical. Am I balanced? I look at it. No, I have this gap here, F net X. Well, what forces do I have horizontally? I have Fa. It's going to the right. I'll call that positive. I have F friction. I'll call that negative because it's going the opposite way. Whatever direction you choose, they should be going opposite ways. All right. So this is what I end up with. F net X is equal to Fa minus force friction. If I plug all this in, I get that F net X, which is your F net, is 10 minus 3, or 7 newtons. If I want acceleration, F net's equal to ma. Acceleration will be F net over m. So 7 over 10, and so you get 0.7. All right. Now, this is a good time to ask ourselves, does this answer make sense? Last time, I had no friction. I ended up getting an acceleration of 1 meters per second squared. Is that the same here? I think it will be the same. So 0.7, or sorry, it's not the same. It's less than what it is, and that's expected because friction is working against the object now. So this makes sense. Hopefully, problem 1 makes sense as well. Now, we could do all the kinematic stuff. I'm going to skip it for now just for brevity of the video. It works out essentially the same way, except everything is smaller or everything takes longer because your acceleration is lower. All right, let's do problem 3. All right, problem 3 is similar to the last one, except now we keep the friction, but we lose our force applied. So we have gravity, we have normal force, and we have force friction. All right, let's solve for all this stuff. Once again, 100 newtons for Fg, 100 newtons for Fn. Vertically hasn't changed. My friction is 3 newtons. My F net is going to be 3 newtons. If I do my vector addition diagram, I see, hey, wait a minute. My gap that I have still, this time, it is whatever my friction is. So it's going this way. So it's going that way, so it's got to be 3 newtons. Now, as far as directions go, and I get this question a lot, like people say, should it be negative? And don't worry about positive or negative unless you are actually in the summing of forces phase. If you're drawing me the directions of these arrows, you have declared a direction for me. I want to avoid y'all doing double negatives. If I say, oh, Fn's 100 newtons and Fg's negative 100 newtons, technically the way I interpret this answer here is, oh, so you're drawing your Fg backwards. So to make it positive, I'm going to flip it upwards. So graphically, you are declaring a direction. You don't need to declare that direction twice. We'll get into this later, but sometimes these positive negatives can help you figure out if you're pointing something in the wrong direction. My acceleration in this case is going to be 3 newtons. Now this is one I would want y'all to specify. You'll get 0.3 meters per second squared. Now, if you specify this as Fnet and Fnet's equal to ma, I would specify this as left, or this might be negative, because technically acceleration, you have not drawn an acceleration vector over there. You have not drawn an acceleration vector going left or right. So when you choose your direction, positive or negative, you need to declare it in this problem. All right, problem 4. This is more conceptual. This is more like us stamping the idea. Do we understand what's happening in these problems? So hopefully 2 and 3 were fine. Let's try to finish off worksheet 1 in one video, in one last video. So they ask us this question. What was the net force? So we're looking at problem 1. So all these are problem 1. They ask us, what is our net force in order to travel with a speed of 3 meters per second? Well, if I go back to problem 1, essentially my net force was 10 newtons. And it was 10 newtons this entire time. Unless I detected my acceleration changing, which there's no reason to think it was changing, I can assume, okay, well, my Fnet was 10 newtons. In order to get to 5 meters per second, it's not really a question of what does my net force need to change to. It's more like, do I have enough time? Do I have 2 more seconds to get up to that speed? So it's still 10 newtons. When I'm at 0.001, I'm still at 10 newtons. They ask us, all right, problem 3, the unbalanced force on the object from problem 3, what is it? Well, my net force is, 3 newtons still. I could say to the left, and maybe for all these you could say to the right, just to be special. All right, that's what I got for y'all, worksheet 1. Hopefully y'all kind of understand this. I don't think the concepts are too hard because we've worked so well with balance and interaction so far, but we're gonna move on. We're gonna look at elevator problems next video, so thank you.